Hello, this is Mr. Huber. In this lesson, we're going to continue looking at exponential functions, writing equations for them from graphs, and also see how exponentials relate to compound interest and applying that to some real-world situations. First, we're going to talk about writing an exponential equation. So we want to remember the general form for an exponential function, f of x equals ab to the x. Remember, a will always be the y-intercept. And then b is whatever that constant rate is that we'll notice, and we'll see how we can get that number so we can write the equation, because the two things we'll need are the a and the b. The a value should be relatively straightforward. We can see from this graph here where the y-intercept is. So the y-intercept right here, where the graph goes through the y-axis, is at 1. I'll put a little dot there so we recall that. So this point right here, that's our y-intercept. A equals 1. Right. Now let's find some other points. So I have a point right here at 1, 2, 2, 4, 3, 8. So if I wrote those in a table, okay, if I wrote those x and y values in a table, all right, so I have 0, 1, 1, 2, 2, 4, 3, 8. Our b value, okay, the b value is what the change is in each of those y values. How am I going from 1 to 2, then 2 to 4, then 4 to 8? It has to be the same thing where I can say we're adding 1. Yes, we can add 1 to go from 1 to 2. But then if I add 1, I don't get the next number, which is 4. Okay, things like that. So in this case, we want that constant change to be that I'm multiplying by 2 times 2 times 2, that means my b value is 2. So I could write the function. Remember the directions here? It says to write a function. Okay, so if I'm going to write the function for this, it would be f of x or y, that's fine, equals 1 times 2 to the x, or just 2 to the x. So the a value, our y-intercept, and then the b value we can find by figuring out what is happening as we go from each y value to the next in our table along our graph. Let's see another example of that here. You should try to write this one out, see how you do in writing your y equals ab to the x, or f of x equals ab to the x. You can write it either way, is fine. All right, now that you've had a chance to try and write the equation for this, let's look at the y-intercept, and that part should be pretty straightforward. So that's an a equals -1. And then if I find some other points along my graph, I've got one right here, got another one right here. Okay, I can pick any points, but I'm going to pick ones where I know I'm right on a grid line. I'm right at -9 and 2. Right? If you pick this point right here, what are the coordinates for it? I don't know. So it's not really going to help a whole lot. So you want to pick numbers you know exact coordinates for, like 0, -1, 1, -3, then follow 2 down till you hit the graph right here. And you could do 3 is off the graph, so that's not going to help us a whole lot. Okay, so you want to make sure that you know how to write out those points. Again, I'll put it in a table. It might make it easier to see then sometimes. We have 0, -1, right, our y-intercept, that's our a value. They have 1, -3. Then we have 2, -9. So how am I going from -1 to -3, -3 to -9? I'm multiplying each of these by 3. Right? And also we recall this is a reflection. This graph, exponentials usually go up like this, is a reflection across the x-axis. That's why we have that negative in front of there. We've seen those before where we can understand, the stretches, shrinks, reflections, translations, things like that. So this reflection, we should be expecting to get a negative for our a value, which we do. Right? And so if we're going to write this equation, we could have y equals -1 times 3 to the x. You could just write that as -3 to the x as well. You can write the 1. It's the same thing. Right? So again, y equals f of x equals, we write the equation, the function. Get your a value as your y-intercept. Your b value is what that constant changes in your y values. All right. Let's look at compound interest now. And compound interest is modeled by an exponential equation that we see here. is our exponential equation for compound interest. So we've talked some about how you can calculate things that are increasing over time. Okay, sometimes maybe you just get calculation of interest every year. Well, compound interest means it's calculated constantly. It's compounded on itself. So we have a little bit of a different formula to use. We'll talk about what those different parts are. Right? We have A, which is the amount in the account at time t. That's the amount that you have. P is your principal, starting amount. So you're starting with $500, that'd be your P value. We'll talk about E here in a second. R is your rate. Okay, remember that's out of 100, so if it's a 5%, that'd be 0.05. And then T is the time in years. So if it's over 2 years or 8 years or whatever, we plug that in. Okay, so R times T. Your exponent here is R times T. The rate as a percent out of 100, and then the number of years. E is an irrational number, like pi. It's a number that goes on. It doesn't have a repeating or ending to it. Okay, it's Euler's number. It's one of the reasons there's an E used for it, Euler. Okay, what this? It's called a natural base, right? So this is the base of the exponential. It's a natural base. There's some different other applications for it with logarithms, which we'll see as well. Okay. We want to use that number in our calculation. We'll talk about what the actual number is as well, but if you just find the E button on your calculator and hit enter, you'll get a decimal that goes on, just like if you hit pi, it goes 3.1415, goes on forever, okay? So we're going to use that in our calculations. So as we go through to do these problems, we're going to want to use that formula, P times E to the RT, okay? And we're going to calculate here for a deposit of $4,000. So that's our principal, our starting amount. It's going to pay 2.9% annual interest compounded continuously, okay, continuously. So that's where we're going to use that P E to the RT formula. So let's write that formula down here again that we're going to use. We're going to use the amount in the account, P E to the RT. So in this case, our principal is $4,000, and then E to the R, 0.029 times T, which is 3 years. Okay, so you can put that all in the calculators. Is you 4,000, and then you'll find a button on your calculator. Make sure you know where it is. If not, get help with figuring out where it is. On the TI-84s that we use most commonly, you'll find it down the left side in blue over the button that says LN in it, a little bit to the left of the 4 and the 7. So you're going to have to press the second, and then that E, it says E to the X. So it's going to put E and then give you that exponent to type in. And you can just put 0.029 times 3 as your exponent, okay? And then when you hit enter, you should get value here of $4,363, and we round off 59 cents, right? Money, we go to 2 decimal places, unless it says to give to the nearest dollar or some other amount. But here, $4,363, and it says 0.586, so that round up to 0.59, 59 cents. Right? If we're going to find the balance after 6 years, that's 4,000. We're still starting with $4,000. E to the 0.029 times 6. So we're going to do 4,000, right? And then we're going to have E to the 0.029 times 6 for our exponent. And that comes out to $4,760.22. So you can see that over 3 years, you would have added $363 to your account. Okay? Over 6 years, it added $760 to your account. It's not just double this amount. It's growing exponentially. So you get $363. Over the next 3 years, you don't get another $360. You get another almost $400. So the longer things are in the account, right, the more it's going to grow even quickly. So know the formula and how to use it, and be able to calculate compound interest in situations like the one we see there. Okay? Before we see another example here, let's talk about what E actually is as a number. All right? Like pi, an irrational number that decimal just goes on forever. And some people have memorized pi to thousands of digits, 3.14159, and you keep going. What about E? All right? So let's see what we can do to help us figure out some digits of E. You might find there's a little pattern here. It's a little easier to get the first several digits of E than it is for pi. Okay? First, we start with the 2.7. E starts with 2.7, and then the numbers 1828 repeat twice. So you can see here we have 2.7, 1828, 1828, and then 45, 90, 45. We're going to add those angle measures, the digits of those angles, 45, 90, 45. And through a little bit of, memorization, right, of this pattern, you can get E to 15 digits. It's hard to memorize pi to 15 digits, but E a little easier. So, hey, an instant way to seem really smart. You can tell people you have E memorized to 15 digits, okay? 2.7, 1828, 1828, 45, 90, 45. And you've got that down all the way to 15 digits. Pretty interesting there. And then after that, you could find other ways to memorize. It's not like that pattern keeps repeating itself, but hey, knowing E to 15 digits may be impressive by itself. All right, let's have you try one here with some compound interest. Find the amount in this compounded interest continuously after 4.5 years with a starting balance of $750, an interest rate of 6.1%. So pause the video, try this one out, and when you press play, we'll see if you in fact did it correctly. Okay, so we're going to start out with our formula, A equals, not P equals, we're going to use P in our calculation. So A equals PE to the RT. I was getting a little ahead of myself there. So our principal in this case is $750, right? That's our starting amount. And then E to the R, which is 0.061, right? 6.1 over 100. We move that decimal 2 places to the left. It becomes 0.061. And then times T is 4.5. That's fine. We can have half of a year, right? 4.5 years, that's fine. So now we're going to have to put this into our calculator, right? Make sure that we're using the right buttons for E. We've got our exponent as 0.061 times 4.5, and you should get a value of $986.90. It's 0.904, so the zero would just stay a zero. So $986.90. Not bad. 4.5 years, $750 becomes nearly $1,000, right? Because it grows pretty quickly. Again, that rate up a little higher. If you want to try something out, try 5.1%, 7.1%. See the difference that just 1% can make in interest compounded continuously over several years. Right? So know this basic formula, okay, for compound interest, so that you can use it. Right? Understand what the parts are that go into this formula, and then back from the beginning, know how to find an a and a b value from a graph, so you can write those equations, the y equals ab to the x equations, functions for graphs if they're given to you.